the Polystars game.
Only not. So, true. We're going to show you an equivalent game that we're going to do with playing cards because they're very easy to handle, and I'll explain why it's the same. Right? So we're going to play the Polystars game, which is basically a Graeco-Latin square. And it crops up all over the place in different disguises for different uses. And we're going to play the same game, or equivalent game, or isomorphic game with playing cards. Now, in the Polystars game, you have polygons, different sorts of polygons, and they're matched by stars. And we've got 3, 4, 5, and 6-sided polygons for the 4x4 game. And
3, 4, 5, and 6 points of the stars.
Exactly. And the challenge is to put them in pairs, first of all, so that each pair is different from every other pair. That's the first challenge. And the second is to put those pairs of shapes, one polygon, one star in each of these squares on the grid. And I put a few in to start you off. So the challenge only now is only to put these 9 in, because those have been done for you. And if you look along here, no two of those pairs are the same. We've got no two have got the same colours, and similarly down here, that all the pairs are different, and you haven't got a repeat of any star, and you haven't got a repeat of any of the polygons.
Now this is just for vertical and horizontal lines. It doesn't work for diagonals on this game, does it?
I think it does for 4.
Oh, it does with 4.
Yes, it doesn't for 3. That's
some
what
it
you've
does
remembered.
and some it doesn't.
Yeah,
I'm just going to show you what, before we move to the cards, is that you've got all of this that you can print out. Up to here, this is it. So you don't photocopy or print out, and it's all downloadable.
And you can do it with 3x3, 4x4, 5x5. And it becomes more of a challenge as you have a bigger board.
This page was relevant, yes, and that's where you've got
up to 5x5
examples of that. Yeah.
Yes, but it's actually easier. Maybe you could start it this way, to do the same puzzle with playing cards. So what I've done here is I've sorted out 16 honor cards, and you see they've each got 2 properties. Here we've got the Jack of Hearts, but here is another Jack, which isn't the same. This is the Jack of Spades. The suits are different. They're both Jacks, but the suits are different. And of course, you're probably used to playing cards. There's another Jack. There's another Jack. Okay? And what we're going to do, they're already in pairs. As we explained, you pair up a polygon with a star, but in these cards, the pairs are already paired up. They're paired up with a suit, either hearts, spades, clubs, or diamonds, a suit with ace, king, queen, jack. So what we've got to do is to arrange these 16 cards in a 4x4 grid so that there's no 2 the same. No 2 the same. Either no 2 aces, no 2 kings, no 2 queens, or no 2 hearts or spades.
So we could work collaboratively, or we could take it in turns to place a card.
Yes, it's a puzzle more than a game. We can turn it into a competitive game, but I think what we'll try and do is make it a collaboration.
So how are we playing it? We're playing it as a team.
We're going to do it collaboratively.
Okay.
All right, let's take the 4 kings out.
Okay.
And put them across the top. Right, you
put them across the top. Okay, I can do that. That's easy peasy lemon squeezy.
Now that's no good, is it? Because we've got kings all the way along there.
Yeah, we're supposed to have a king, a queen, a jack, and an ace.
Right. So let's go back to.
Oh, but can I? Would that be an idea since we need to have a
A king on each
every
line.
row?
That's a good idea. But now we've got kings down there. So let's
But
try and avoid that.
oh,
Let's try and avoid having everything the same on the diagonal. So let's put an ace. So it's the ace of diamonds, the king of spades. Now this is different.
we could put the queen of hearts.
Yes, and so what do we want to finish that line off? The jack of.
The
We're forced into it.
jack. Oh yeah, that's it.
So
Just
it's
the
a jack
jack.
of spades.
Let's see, the jack of spades, and then just the ace of hearts. No, no, it can't be jack of spades either. So that's not right because the jack of we need a jack when it can't be the jack of spades.
Exactly. So we've got to do something a bit cleverer now.
Okay. I thought I was doing something
It
clever.
seemed like it, didn't it? Okay, it did seem like it.
Oh no. Is that okay?
I think we're going to
No,
stop
because
it.
we've got two hearts.
Well,
Well, I think we've demonstrated that it's not as easy as it looks.
right.
That was hard.
There are actually 144 different solutions.
And we can't even find one. There are 144 solutions
Well,
and we haven't found one.
We haven't been working at it for very long, Caroline.
Right.
And I've never actually done it before. I just knew it existed.
Right, let's have another go. We can do this, Tony.
We can do it. We're going to start with the ace of clubs. And we're going to start with an ace, king, queen, jack.
Okay, ace, king.
The queen, a king of. We're going to start with a king. Put the king of spades there.
Yeah, let's do the two black ones together.
And then this queen, right?
So it's got to be the jack of hearts.
Okay.
Okay. Okay, that's it. I'm done. I can go now.
No.
Oh,
We've got a little bit more to do.
No.
That's right. There's
3 more rows.
Right, now. So let's now bring that jack to this end, and we're going to, I mean, not bring it, but actually we're going to put a red jack there.
The last row should just be whatever card is missing and see if we've got it right.
Now, on every row, we've got an ace, a king, a queen, and a jack.
Yeah.
On every column, the same applies.
Yeah.
And we've got a different suit, 4 different suits on each.
I think we've got it right. I think we've sussed it.
We haven't.
And that's the first solution of 144.
Exactly.
We've got our work cut out, Tony.
So one of the challenges here is to see if you can find a different solution, and how many are there.
And there must be a pattern. There must be a system that you can use to help you. Because we started off really randomly, but I still haven't got a system. Although that's the reverse of that. And then the swap around, and that is the reverse of that. It's just in terms of the type of card, not the suit. So there might be something there.
So this is exactly equivalent or isomorphic to the Polystars game. So you could do this by trial and error. You could, theoretically, if you were persevering enough, find 144 solutions by trial and error. But there's more mathematics in it than that. What you can also do is think about rotating this solution and getting actually different layouts, but the same layout repeated, just turned through 90 degrees. So we've been looking at it this way around. But imagine 4 people sitting around this table looking at it as you do when you play a game from their own directions. They would actually see this layout of cards 4 different ways round. So imagine 4 different people sitting around this table playing a card game, or same applies to a board game. They all see different views. Now, the first view has the ace of clubs in the top left-hand corner. Now, Caroline is going to look at this from somebody else's point of view, sitting at the same table, looking at the same layout, and now the Jack of Hearts is at the top left-hand corner. But turn it through 90 degrees again, and we've got somebody else's view sitting at the table, looking at the same solution, but it's not the same. He has got the King of Diamonds now at the top left-hand corner. And finally, turning it through another 90 degrees, the fourth person sees it with the Queen of Spades at the top left-hand corner. These are not distinct solutions, in fact. They're rotations of one solution. And that's a sort of mathematical idea, of course. But now if you imagine somebody lying on their, this being a glass table, and somebody turning over the cards, and somebody lying on their back, looking up at, well, this isn't a glass table, but they can see the layout. What they actually see is a reflection of this layout, and it looks different. So you can reflect this layout, this picture, in an axis from to the middle, from top to bottom, or from side to side, or on a diagonal, one of the diagonals. So there are 4 different reflections involved. And then you can combine both, you can combine rotations with reflections. So actually you'll find all the different solutions by doing some mathematics with reflections and rotations. Now, what you can do with your younger children is start off with 3 by 3 and not have 2 things on each card, each square of the grid, but only have 1. Or you could do it with the shapes, and you would have a triangle, a square, and a pentagon, and make sure that no line, a row or column had 2 squares on.
So you'd have different numbers of different colours. So you'd have 1, 2, 3, and they're different colours, for example. Okay.
One manifestation of this is something called Auntie's Teacups, which the Enrich project has made popular around schools around the country.
I want to play Auntie's Teacups.
Oh, it's lovely. So you have 4 colours, right? And you have
the cup and the saucer, and different colours.
4 cups, 4 saucers of each colour, and 4 cups of each colour. So, as we showed you with the Polystars, instead of a polygon and a star, you have a cup and saucer. And so you start off perhaps by putting a saucer in each square, so that there's no 2 lines, no 2 rows, no 2 columns, no 2 diagonals, have 2 saucers of the same colour. And then you put the cups on top.
That sounds like a lot of fun. I enjoy doing that.
Yes.
I want to play that game.
Well, we'll put the link for you so you can go to the Enrich sites to play that game, to see more about it and to play that game. Now, if there's only 1 object in each square, but they've got no repeats, that's called a Latin square.
Okay.
And if there's 2, it's called a Graeco-Latin square.
So where you have the king and the heart, that's a Graeco-Latin square.
Yes, 2 things.
And it's going to be a square, never a rectangle?
Oh, no, it's always a square. So it's 3 by 3, 4 by 4,
okay.
5 by 5. And the reason that it's been given this name, Greco-Latin, is because you can do two symbols, like a letter A and a Greek alpha.
Okay.
B
Oh, no.
beta.
Oh, yes,
C.
Greco-Latin. Yeah, duh.
Yeah.
Yes, nice.
Yes. Greco-Latin squares are used in design of experiments.
Really?
Yes, by engineers, scientists of all sorts, computer scientists as well. So
That's interesting.
Let's take, for example, medical research. So there's a new drug, and the drug company wants to test it. So they use 4 different doses and 4 different age groups of the people who are given the doses,
Okay.
and arrange it so that the 4 different doses are put in the square so that no row or column has the same dose.
Okay.
And then they put the people in so that no age group is, the same age group doesn't appear in any row or column.
Okay.
And then every age group gets tested with all 4 different doses.
Okay.
Isn't that clever?
Yes, it is. And it's that I love real life uses. If you can think of a real life use, please put it in the comments.
So we'll do another video about Polystars
Another time.
Because
I've got to do lots of preparation for that. And that is the Polystars game, but we played the... What's that game called? Is that got a name?
I just call it playing card Greco-Latin, but I don't know whether that's it must have had other names.
That's not a long name at all. Playing card Greco-Latin.
And apparently it was very popular in the court of Catherine the Great in Russia. And there were various versions of these puzzles around at the time.
Okay, and you can play it with 3, 4, 5, larger and larger squares to make it more challenging.
Yes.
Lovely. Thank you.